In today's rapidly evolving tech landscape, the way we structure information has never been more important. With AI models growing more powerful and prompts becoming increasingly complex, developers and businesses alike are searching for ways to keep processing times and costs low. Structured data formats have become the backbone of efficient AI workflows, ensuring that both input and output are clear, organized, and easy to interpret. But as we continue to push the boundaries of what AI can do, the question arises, are our current data formats truly optimized for this new era? This video explores the evolution of structured input, focusing on the comparison between JSON and the emerging TOON format. As AI becomes more integrated into our daily workflows, the importance of structured data cannot be overstated. When working with large language models, having a well-defined schema for outputs like JSON makes it much easier to process and analyze results. But while we've mastered structured outputs, our inputs often remain messy, with large, unwieldy datasets slowing down processing and increasing costs. This inefficiency has prompted the search for new, more streamlined input formats that can keep up with the demands of modern AI applications. JSON, or JavaScript Object Notation, has long been the go-to format for structured data exchange. Its human-readable syntax and compatibility with most programming languages have made it a favorite among developers. JSON allows for clear definition of fields and values, making it easy for both humans and machines to understand and process information. However, as datasets grow larger and more complex, JSON's verbosity and reliance on punctuation can become a bottleneck, especially when working with AI models that are sensitive to token counts. Despite the advantages of structured outputs, most AI prompts still rely on large, unstructured inputs. Developers often feed massive JSON, YAML, or even plain text datasets into their models, leading to inefficiencies in both speed and cost. This approach is far from token efficient, as it increases the amount of data the model needs to process, resulting in longer response times and higher expenses. Clearly, there is a need for a more efficient way to structure input data for AI systems. Enter TOON, a new file format designed to address the inefficiencies of traditional structured input. TOON sits somewhere between JSON and CSV, offering a human-readable format that is optimized for both large language models and tokenization efficiency. By reducing redundant punctuation and leveraging indentation-based structure, TOON promises to make data input faster, cheaper, and easier to manage. Its creators claim that it can reduce token counts by 30–60%, which can translate into significant cost savings for AI applications. TOON stands out for several reasons. First, it is highly token efficient, typically using 30–60% fewer tokens than JSON. This is a game changer for anyone concerned about token pricing and processing speed. TOON also introduces LLM-friendly guardrails, with explicit lengths and fields that enable easier validation. Its minimal syntax removes unnecessary punctuation, making files cleaner and more concise. Additionally, TOON uses indentation-based structure, similar to YAML, and supports tabular arrays for efficient data streaming. To better understand the differences, let's compare a simple dataset in both JSON and TOON formats. In JSON, each entry is wrapped in braces and separated by commas, with field names repeated for every object. In contrast, TOON declares keys once and streams data as rows, using indentation and minimal punctuation. This not only makes TOON files shorter, but also easier for both humans and machines to read and process. One of TOON's biggest advantages is its token efficiency. By eliminating unnecessary punctuation and leveraging a more compact structure, TOON can reduce the number of tokens required to represent the same data by up to 60%. This has a direct impact on both cost and speed, as fewer tokens mean lower processing fees and faster response times from AI models. For businesses handling large volumes of data, these savings can be substantial. TOON is designed with LLM-friendly guardrails in mind. By specifying explicit lengths and fields, TOON makes it easier to validate data before it is processed by an AI model. This reduces the risk of errors and ensures that the input data matches the expected schema. For developers, this means greater reliability and less time spent debugging data issues, leading to smoother and more predictable AI workflows. Another key benefit of TOON is its minimal syntax. By removing most braces, brackets, and quotes. TOON files are cleaner and easier to read. This not only makes them more accessible to humans, but also reduces the cognitive load on AI models, which no longer have to parse through layers of redundant punctuation. The result is a format that is both simple and powerful, striking a balance between readability and efficiency. To put TOON to the test, a simple benchmark was conducted using an employee dataset. The task was to analyze the data and calculate the average salary by department using GPT. The results were impressive. TOON reduced prompt tokens by 56% compared to JSON, and the overall response time was 5 seconds faster. Importantly, the output quality remained the same, demonstrating that TOON's efficiency does not come at the expense of accuracy. TOON is already being adopted in a variety of programming environments, including .NET, Python, and Go. Its token efficiency and ease of use make it ideal for applications that regularly feed structured data into large language models, such as chatbots, AI-assisted code generation, and multi-step workflows. By reducing prompt size and speeding up inference, TOON helps developers build faster, more cost-effective AI solutions. The financial and operational benefits of TOON are clear. By cutting token usage nearly in half, organizations can save significantly on processing costs, especially when dealing with high volumes of data. Faster inference times also mean better user experiences, particularly in real-time systems or streaming APIs. For businesses focused on performance and efficiency, TOON represents a compelling alternative to traditional data formats. As we continue to optimize the way we interact with AI, formats like TOON are likely to play an increasingly important role. Whether it becomes the new standard or remains a niche solution, TOON's focus on efficiency, clarity, and ease of use sets a new benchmark for structured input. Developers and businesses should keep an eye on this evolving landscape, as the tools we use to communicate with AI will shape the future of technology. In summary, the evolution from JSON to TOON marks a significant step forward in the quest for efficient, structured input for AI systems. TOON's token efficiency, minimal syntax, and validation features make it a strong contender for the future of data formatting. Whether you're a developer, a business leader, or simply interested in the latest tech trends, understanding the benefits of TOON can help you stay ahead in the ever-changing world of AI.